different. I don't know if you've heard anything about today.
I just asked them.
I don't either, actually. It had to be something.
I thought it was that cool.
Alright, so in this, I'm going to do something different that we've never really done before that may seem odd to you. We're going to start with a super hard problem. We're going to start with one of the hardest problems I can give you in this. Why? Because it's going to show you what we are working towards, and then we're going to flip it backwards. It shows you so that when we're building, you're not caught off guard. Like, oh God, what is next? You know what is there, you know what is coming, and then you're like, oh hey, there's hope.
This ain't that bad.
So
what verse did Mr. Stewart have to tell you to give us hope?
He hasn't told me yet.
Has it been this year already?
No, he hasn't told me yet. He may have just gave up. Who knows?
Well, I'm gonna go beg Tim to take me out of here just because when he's so hard I'm gonna end up crying.
All right. So on this. And when we go from moles to atoms, particles, formulas, and we can go backwards. So pretty much everything on here you've seen. This is the last piece for your mole math.
Does your earphone not work?
Oh, no, it works.
Oh, did you just have it turned off?
I don't know what you're talking about.
It's
Nope.
I mean, that don't make any sense.
Why don't you have it turned off? I'm just curious.
I don't know what you're talking about.
Okay, why would a teacher turn off the intercom?
I think you even started off.
You may not, but what would be a good reason for a teacher to turn theirs off?
I don't know, it'd be a gift from God if that teacher could turn it down at certain moments so that there's not 13 interruptions.
Okay, anyway.
Alright, so on this, here's the thing. You're going to do what you've done the whole time. We're going to set up two different conversion factors. So, first conversion factor, up here. And I'm going to make this a little big because of the units that go with it. There's a special number that comes with this. So yesterday we introduced that first number that you had to memorize. 22.4 liters per mole. And that was for a gas at standard temperature and pressure. At this, there's another number. If we are going to go from moles to atoms, molecules, particles, and forming units, and I do not remember what I did, I have my arrows flipped. Hold on. Compared to yours.
It matters.
No, that was
It does matter.
That was right. Why does it matter? You had it right.
Yeah. Mine was right. With how you had it.
May I ask why it matters?
Well, right. Add the points at different ends. It matters because of the direction that you're going.
Well, you put it on the other, not the other one.
That is not what I'm seeing on theirs.
That's what I
I have it the other way.
That's what
Not that way.
Alright, so here's the thing. Okay, we're going to go from moles to atoms, molecules, particles, and forming units first. So we're going to do the red part. We're going to do from here to there. So in this, whenever you're going that way, we're going from moles. We want moles to cancel. What has to go on the bottom?
Your moles.
Moles. And what number always goes with moles in our conversion factor? 1, because he was number 1. Now, at the top, what units go there?
22.4 liters.
No. What units? So it depends what you're being asked for, okay? So it's either atoms, molecules, particles, or formula units, okay? I'm just going to put 3 dots because you know it's going to keep going on. There's a special number that goes with this. I'm going to show you the abbreviation of this number, and it's very crucial that you know the difference for it, okay? Because when I was in college, I was a TA for a chemistry lab, and these freshman lab students turned in lab reports that I had to grade. And I got instructions from the professor, if they put the long abbreviation for this number, I was supposed to take off a point. There was kids that, no joke, had 100% on their lab report, until I totaled up how many points they lost for putting the wrong abbreviation. I had a kid that got a 33%.
Oh.
That sounds like me.
So, yes, he literally lost 66 points, 67 points off of it, okay? So this is why I'm stressing this to you. The abbreviation for this, it's called Avogadro's number. Avogadro's number.
I know.
Avogadro.
Let me spell that.
What's Avogadro's number?
6.022 times 10 to the 23rd power.
Well, look at you.
I've been waiting to say it.
It's a capital N with a sub capital A. So it's going to look like this.
What kind of A is that?
It's a capital A, but it's a sub, like subscript.
Itty bitty.
This is not this. The importance of this is that you know this is Avogadro's number. This is the element sodium. Everybody wants to put this in this is wrong. Please make sure you do not mess that up.
I remember somebody telling me about that. They were mad at you.
Oh. Once you learn it,
Don't forget it.
oh, it's fair game.
So N little a is sodium.
Yeah. All right, so in this, let's look and say that we're going to go from atoms, molecules, particles, formula units to moles. If we're going to do that, what unit's going to go on the top? Moles. Why is moles on top?
Because
That's what we want. That's what we want to be left with. What number goes with moles?
1.
1, because he is number 1. You better remember it. It's either we're going to go through moles, we're going to moles, we're going from moles. This all deals with moles. In this, the bottom of it, guess what's going to go on the bottom?
Atoms, molecules, Na.
Atoms, molecules, particles, formula unit, and Avogadro's number. So, Avogadro's number is the number. I'm going to give you your number here in a second. But it's atoms, molecules, particles, formula units, all that. It depends what you're starting with.
We just put AT.
I'm fine with that as long as you understand that this right here is going to be the units. And this is how you're going to figure out if that's the units or not. I'm either going to start you with them or I'm going to ask you for them.
Oh, God.
It's literally that simple. Like, you don't have to guess. I'm starting you with you or asking you for them. So in this, I think I'm going to do it'll be really good because you're going to have the second period video. We do a good fifth period video here. This will be good. So note, Avogadro's number is 6.022 times 10 to the 23rd. And it's either atoms, particles, molecules, formula units.
I'm just curious how Kristen do that.
She's friends with people from second period.
I'm just nervous.
Oh, whatever, Christy.
I learned it all the time.
I remember you teaching us in that thing. You know that thing where I made the perfect titration?
Yep.
I just forgot it.
Okay, in this, these are the units that's going to go with this number. Anytime you're going to here, this is Avogadro's number. You must memorize it. You must know it. It has got to be there. Okay? No ifs, ands, or buts about it. Alright? That completes your mole map. Now with this, I'm going to go on and tell you. Okay? In second period, we did something different. I'm going to do a different hard problem in here so you can go back and watch the videos and see the contrast. Before anybody gets ticked off at me saying, well, you're not doing with that, what you did with them. That's right. They're going to have to come back and watch your video as well. Anybody that wants to get mad at that fact, in class, you're going to end up doing it, okay? I know we're doing a lab tomorrow, but it doesn't mean that we're done with this. We're coming back to this after the lab. And then we're going to carry on with this. Alright? Now in this, I'm going to need the whole board. That's how good of a problem this is. So you're going to want your mole map. You're going to want a calculator. You're going to want a writing utensil. And above all else, you're going to want your brain. May want it. So first in this, I'm going to literally show you tricks with this first problem. This problem is the Mad Daddy essential of it all. It's real deal. I'm going to knock you in the face, not playing around. So if I asked you a question, how many molecules of, and I'm going to give you something here. I'm going to give you an actual molecule, okay? Like in the first and second period in that video that will be released tonight. So if you want to go on and watch it, it'll be there. I've already got it on YouTube. I got it scheduled to come out at 3. We use this molecule, and I still want to use this molecule because it's a gas. So we can have great use out of it and we can work a different problem with it. How many molecules of propane? Hank Kill's favorite thing.
So that equals propane?
C3H8 is propane. Rn. Oh man, let's just make fun.
Oh.
I'm not even going to change.
How many molecules of propane are in 1,789.3 times 10 to the 6 centimeters cubed of
Well, I
propane?
need to go ahead and tell you that centimeters cubed means 1 milliliter. Is that right?
Just very wise. You spotted a trick.
All you have to do is do
Alright, here's the first step you're going to do.
10 times 10 times 10.
If there's anything you're going to do, this is going to be your first step. And for some reason, so many kids want to just jump off this. Don't just start jumping into a problem and trying to figure it out along the way. If you're going to ride by the seat of your britches, you're going to get your britches tore in this case. Find where you're going to start at. Where are you starting? It's the number I gave you. It's the units I gave you. It's the information I've given you. What have you started with? There's your starting point. Now my question to you, of which of the 4 boxes, mass, moles, atoms, molecules, particles, formula units, or volume of a gas is this?
Volume of gas.
It's volume of a gas. Very nice. How do you know it's a volume of a gas?
Because it's propane.
Because it's propane, but you named it earlier. It's a volume measurement. It's literally a milliliter. Probably a milliliter. Where are we ending at? What is our stopping point? Where are we wanting to go?
Molecules.
Molecules. Don't freak out. So we're starting at volume. And we want to go to,
So we need to go up and left on our map. Up to moles and left to,
should be right.
oh,
Up
it's
and right.
molecules, my bad, okay.
So volume of a gas, we want to stop at molecules. Now, Hunter, I think it was you that said this. What's the key to this? If I'm going to get to molecules, what do I have to go through first?
Need a custodian in the
Oh.
office, please. Need a custodian.
If we do not roll through moles, you cannot be successful at this. You have to go through moles. This is the part where, this is why we call them mole conversions. Everything's going through moles. Now in this, you're going to hate me when I do this. You spotted one trick, but there's a trick lying in the trick. I'm openly telling you this. This is being recorded right now as long as nobody ruins this video. Yes.
Do you just leave it? Is
No.
that the trick?
He would just convert it to moles instead of turning it into a milliliter.
We're going to have to convert it to moles.
Okay.
But how can we get it converted to moles? Remember, this is a hard problem. Your first trick, you already noticed it. This unit cannot be here. Write the number down. 1,789.3 times 10 to the 6. I've done this on purpose. I gave you a hard number like that. Already make that conversion of that unit. We can't do centimeters cubed because what is our box in?
20 liters.
It's in liters. But what is centimeters cubed equal to?
Milliliters.
Milliliters. Now hopefully you're catching the trick in the trick here. What is the box in? Liters. It has got to be in what before you can convert?
Grams.
So you got.
Liters.
You have to take.
We were split. You have to have it in grams first if we're on that side, but we're not on that side. You're correct in that. We have to be in grams if we're dealing with a mass, but we're not there. We're at the bottom, and we're having to be in liters. Okay? So what do you have to do?
Is it what we just learned like a week ago?
It's exactly what you just learned a week ago, but this is where it becomes more hard and more complex. You caught the first trick. You seen centimeters cubed and went to milliliters. But you also have to see that you got to take it from milliliters to liters. If you have to do this, create the problem as you've seen them represented. I'm not going to give you this. You have to notice and do this. If you need to do that on your paper. Whatever it takes for you to be successful. Finish?
So it would just.
Did she get that?
So in this, do what you've done. Write the number down. Times 10 to something or other. Now we're going from milli. What is milli? Negative 3. We're going to subtract the other prefix. What's the other prefix? 0, because it's base unit, which gives me negative 3. There's no square, there's no cube there, so I don't have to worry about multiplying by nothing. Plus 6, because we're going to add what we originally start with, so it gives me 3.
I got that right.
That's awesome. At this point, you should get that right. We've went over this. It all comes back together. That's where I'm telling you. I'm laying that trick. I told you, if I don't get you before with it, I'm going to get you later. There's a trick and a trick there. Now we're in liters. Can I do something with this now?
Yeah.
Yes. But you got to notice that you got to get it there first. Now from there, let's start working this thing. I'm going to do teal. I like teal. I don't know if it shows up good though. I'm going to do blue because I think blue will show up better on the board. Alright, on this. This is the important aspect. Here's how you're always going to start these conversions. No matter where you're starting at, take your number, take what you start with, write it down. So you're starting 1,789.3 times 10 to the third liters. Once you write that down, set it over 1.
The top is always what you want to keep right.
So you just put over 1 mole.
What is it? Give me.
The top is always what you want to keep right. And the bottom is what you cancel out.
Mm-mm.
Is it the...
It's the opposite.
Okay.
Alright, on this, you're going to find out that I'm a neat freak and I'm OCD about my units. I just can't leave leaders here. I also have to put what I'm looking at. So C3H8. Later on, this is going to come into play. Okay? Now on this, you're going to do what we said before. Okay, so you're starting at the bottom. We're in liters. We need to get to moles. So we're going from liters to moles. So you can look at your mole map, but like what I told you, it's just a thought process. So I'm literally going through the thought process here. I'm going to set a conversion factor. What do I want to be left with? So where does moles go? On the top. Okay, if you're confused there, this is what you're looking at. What you want to be left with, you want on that top. What you want the cancel is going to go in the bottom. So what are we going to put in the bottom? Liters. Somebody already said it. What's the number that goes with that? Hold up. Y'all got me. I got so juiced up, I forgot. I messed up. I didn't tell you this. At STP. My bad. Remember, I have to tell you that in order for you to be able to solve
So
this.
if you don't tell us that, do we just put can't work it out on it?
Exactly. That's exactly what you'll do.
That's good.
If I give you values for it, so if I look at you and tell you with temperature at blah, 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 and pressure at blah, 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 you look and say, cannot solve, not at STP. Okay? Just the volume. Just the volume. If I got you at grams, you absolutely can solve it. It doesn't matter what I give you.
Wait, what? In grams?
If I start you at grams and I'm asking you to go anywhere besides to a volume, it doesn't matter temperature, it doesn't matter pressure, it doesn't matter.
Does it matter if you use STP?
Not on those, but on volume of gases it does.
That's the only one, right?
Yes. Volume of the gas is where we care about standard temperature and pressure, and we also care about sorry. Beat in lead. Alright, in this, what number goes with moles? 1, because he is number 1. Now this is the thing that you can do.
You didn't say it right.
He was number 1. So in this, you can break this into 2 separate things, okay? You can solve this, get the answer, and then set up another conversion factor. I don't like to do that because I feel like it wastes my time. So notice what's happening here. Go back to your math. You have liters of propane on the top and liters of propane in the bottom. What happens to them? They cancel out.
Do you not just cross multiply? Ain't like math class.
Don't have an equal sign. Oh. Okay. Let's set up our last conversion factor. Okay, this is the thing. Where am I at now?
Moles.
I'm at moles. So I've made it to the middle. Now I'm trying to go where?
To the right.
To the right, which is molecules. We're going to set a conversion factor. What do I want to be left with? So what goes on the top? I want to be left with molecules, so what goes on the top? Molecules. You're okay. Listen, if you're making mistakes now, guys, you're fine. This is expected. Don't shut down on me. Stay in the game. What goes on the bottom? Moles. Why do we put moles on the bottom?
You're already there.
I'm already there and I want them to what?
Cancel out.
Go away. Cancel out. We want them gone. What number goes with moles? Because he is number 1. What number goes top?
0.02.
Yeah.
C3 that and the H8 that cancel there.
It cancels here. But moles of C3H8, it's all about propane in this case. So like I'm just so OCD that I like to have it continuing on. So When I'm going from liters of propane into moles of propane, I'm still left with moles of propane.
So
Well, from moles of propane to molecules of propane, it's molecules of propane.
So you still carry those.
Still carries over. The propane keeps carrying with it, but those units are changing. So liters to moles, and now we're going to go from moles to molecules.
So do you just basically forget about that 1,789.3 altogether?
Nope, it's there. That's the number you start with.
Oh
It's going to
my
come
God.
into play when we punch it in the calculator.
Oh, okay.
So in this,
6.022.
6.022 times 10 to the 23rd. Way to
This
go,
is
Chris.
complicated. I want to.
This is complex. This is complicated. This is one of the hard problems. I didn't mean for it to be easy or simple. Like I said, y'all are going to be the best. Ain't no chemistry kid in the state is going to be able to look and say, we're better than you. They lost their mind. Now in this, I want to stress something to you. So right now you're seeing up there. You're seeing the problem. Well, I got to show you how to punch this in a calculator properly, because I'm going to guess a lot of you do not know.
Wait, would the moles cancel out?
Yes, moles will cancel out. Let me go up there and mark it out. I'm sorry, I jumped, Christy. It's my fault. Nice calling me out. All right, moles cancel out. Now the moles cancel out. Here's what we're going to be dealing with. If you're watching the video, close your eyes. It's going to get a little bumpy. That wasn't as bumpy as I thought it was going to be.
It's the only reason we'll watch that video.
Alright, on this. Mikey, would you care to turn the light switch off while you're up? I'm sorry, I should have got you before you got there. I'm literally going to show you what I'm punching and what I'm hitting on here.
How funny would it be if we had
Alright, here is the calculator. Man, this is showing up 1,000 times better than the other class.
That's
Let's
because we
get
are
periods
1,000
better.
better.
Just take a period.
Alright, so on this, I'm going to show you how I'm going to punch this on. Now, if you're watching the video, you should literally have your notes in front of you, have the paperwork in front of you, so you see what I'm pulling from. I'm literally going to go with my problem here. Now, I am a parentheses freak. I use them constantly, so judge me if you want to. I don't care. So the first thing I'm going to do, I'm going to start with the parentheses right there above the 8. Now we're going to punch this in scientific notation, but you need to learn how to do scientific notation properly on your calculator. So the first thing you're going to do is type in the number. 1,789.3. So 1,789.3. Hopefully I don't have to slow that down and show you how to punch that in a calculator.
Where is the parentheses?
It's above the 8.
Okay, I found it.
Alright, now on this, here's what you're going to do to hit scientific notation properly in a calculator. You're going to hit the second function button that's right here. It's right below the y equals. You're going to hit second function. You're going to get your little black box there is going to be blinking with an arrow in it. It's just a second button. So if you don't know what that does, whenever you hit that second button, that's a second function button. What it does, it turns your calculator to where whenever you click on anything on here, it's going to pull from what is blue. So in this case, this comma right here above the 7, that comma, if you look close, you can see 2 capital E's. That's what we're looking for. So hit it, and you should have a capital E next to the 3.
What's wrong with that thing earlier when I try to like work out the problem on my own?
Now in this, that E takes place of the times 10. And I'm going to stress this to you. On your paper, whenever you're turning an answer into me, you do not put E as times 10. If you're writing it on paper, you put times 10. Okay, these are 2 separate things, yes.
Why can we not put E? Why is
Because
it
this,
separate?
your paper is not a calculator. just ain't how people want it represented.
Okay. Continue.
Now in this, you type in the exponent after the e. It doesn't matter what the exponent is. If our exponent was -7, you would hit the negative key and then hit the 7. But in our case, it's not a negative number. That's how you input a negative number. So you don't got to worry about that -7. Our exponent is what? 3. So nobody freaks out. We're back to what it was. You just hit 3, which is the exponent.
So it's okay if it's a big E? Or a big 3?
Sorry.
It's okay if it's a big 3? Because normally your exponent's little.
Yeah. Because it's reading what comes after that E, and it's saying that's the exponent. Now in parentheses. Now this is how I do it. Because this is how I like to do it. And it works out good for me, and I get the right answers 98.7% of the time. I'm just estimating. I do get wrong answers every once in a while. Not because I punched something wrong in the calculator. Now here's the key. Look back at your paper. So that number is in the numerator. That number we just typed in, it's in the top. Now go to your next conversion factor. Is the number in the top or the bottom? So it's in opposite sides, which means we're going to divide. So let's hit the division key. Now that we've hit the division key,